Let's look at facility work planning. Work planning is the creation of work items in a building and the order in which that work should be completed. The traditional method, the one that's been around for years, is based on the deficiencies found by inspectors. Deficiencies are items which have been found to be in disrepair or are inoperative. The inspector finds items that are broken or are in some other way not good enough and records them as deficiencies. And then he or she estimates the cost to repair or replace them. That list of deficiencies becomes the work item list. It is entirely dependent on the perspective and experience of the individual inspectors. So there can be great variance in the results if multiple inspectors are used across your property portfolio. One of the most important results is the Facility Condition Index, or FCI. The FCI is the cost of required work, maintenance, repair, and replacement, divided by the present replacement value of the building. In this traditional model, required work is only the deficiencies that were seen and recorded by the inspectors. On the other hand, Builder uses an engineered, repeatable, transparent, and defendable approach to work planning. In Builder, the software looks at every single building component. Every building component is evaluated using a series of algorithms. We're going to represent these very complex processes here as a series of boxes. The first box is called the work generator. The Builder algorithms are guided by a set of rules that have been put in place by the Builder user. These rules begin with standards, which are specific condition values that act as triggers for generating work. They will be compared against the actual condition value of the components in the building. Policies are the rules for how the standards are to be applied to the different kinds of components. These rules will be applied to each component once the conveyor belt starts up. The output of this box will be components that do not meet organizational expectations for condition. The organization's policies establish the condition standard that each component must meet. Each of these components, which are now called work items, also have an associated cost for the repair or replacement work needed. Components that meet organizational expectations are not selected for work and move out of the process. You probably have thousands of components in your buildings, but Builder completes this process in just a few seconds. The next box in this series is prioritization. This set of algorithms will determine a prioritized order to arrange the work items, based on the importance placed on certain attributes of the components themselves. These rules, which are planned and selected by the organization, are called the prioritization scheme. The prioritization scheme embodies the fiscal, business, and mission-related principles your organization considers most important. For instance, your organization's leadership may consider avoiding the risk of building failure to be very important, or the maintenance of critical systems in your buildings may be a top priority, or the completion of work items with the highest return on investment may be a concern. These and other principles can be enforced in the prioritization scheme. Each work item is compared to the scheme to determine its priority score. The output for this process is an ordered list of work items ranked by priority. At this point, the system knows which components need work, how much that work costs, and in what order the work should be completed. These prioritized work items then move down the line to the final process, where Builder assigns funding to them. Your organization tells Builder how much money is available for each year and any restrictions on that funding. The prioritized work list moves into the last box, and funds are applied according to the amounts available from the organization. Top priority work items get funded first, and all monies are used to fund as many of the work items as possible. When the money runs out, the leftover lower priority items remain unfunded. In the end, two work item lists emerge from this box: the funded work items and the unfunded work items. In total, these two lists are what it's all about. Taken together, they represent the amount of work that your facility needs. These lists can then be used for project planning, fiscal planning, or long-range scenario development. Builder can also use the unfunded work to calculate the FCI. The cost of the unfunded work items becomes the numerator in the FCI equation. Of course, if this funding is not used for some reason, then Builder assumes that all the work items generated are unfunded. This FCI value is firmly based on the consistent application of your organization's business principles, making this FCI calculation even more significant. Now you can see what we mean when we say that Builder is an engineered, repeatable, transparent, and defendable process. Ultimately, Builder allows you to create a customized and concrete plan for spending your organization's limited money in the most efficient way possible.